2019. So we'll have we'll have a reception following the ceremony, which you're all invited to. Graduates will be called up by name during the ceremony to receive their diploma, and they can say a few words if they wish. And Jose, our undergraduate student assistant, will take photos of the individual diplomas and distribute them afterwards. To our graduates, you have completed a rigorous course of study and grown as, and scholars and more broadly as humans. You don't want to stand through this. You've completed Starfleet Academy in astrophysics or planetary science or both. You've learned about everything from subatomic particles to the cosmic horizon, some 13.8 billion light years distant. But while you've accumulated a great deal of knowledge, the most important skills you've gained are that you've learned how to think critically, how to think scientifically. You've learned how to approach difficult problems and how to learn on your own. You've also embraced the discomfort of the unknown, that in science we disprove or support a hypothesis, but we are always open to revising our theories based on new evidence. Your skills will make you much sought after in a variety of professions, including teaching, research, innovating, and developing policy. But beyond the skills, as part of your liberal arts education here in the College of Arts and Sciences, you've gained perspective and insight into humanity's place in the universe. Astronomy is an age-old endeavor in a field that touches us all. I was reminded of that recently by the amazing image, the first ever image of humankind of a black hole, supermassive black hole at the center of a nearby galaxy. And it was fascinating and awe-inspiring, not only scientifically, but it really clearly touched us as humans and as the public. So you are now our experts. You are our ambassadors. You are trained scientists with a truly cosmic perspective. So congratulations to our graduates. Okay, so next I'm going to introduce Nick Conant. He's one of our theater operators, and Claire Lamont, who's one of our undergraduate graduating seniors this year, who are going to give us a short presentation on our beautiful dome.
Before we get started, I'd like to just point out that we're about to go into the dome portion, which will be very dark. So if everyone can please take note of where the exit signs are in this theater. Notice how they're not above the doors, but they're above the walls. So please be mindful of that. Also, please no flash photography while it's dark. You can take plenty of flash photos while after the fact, after Claire's presentation. But let's welcome Claire Lamont.
Thank you. Working here at Fisk has been by far the highlight of my time here at CU. Nick and I had a lot of fun putting this show together, but I'm not the only person from our team graduating today. If you're not too shy, could the other Fisk people stand up? Ooh. John, Vera, Julia, Sean, Carlos, these people have done everything here. Presenting, operating shows, working in the office, outreach. It will be difficult to fill their roles, but impossible to replace them. I'll miss you guys. All right, let's look at some space. A lot has happened in the past 4 years. When most of us entered college, we had never heard the sound of two black holes colliding, knew what MU-69 looked like, or had ever seen a black hole. As we worked up to our degrees, all of us grew, and with us, the field of astronomy. So today, we are going to look back at some of the milestones, headlines, and major discoveries that have happened during our time here. There's a lot to cover, so where better to start than the star of the show? Our sun, the supermassive flaming ball of plasma that our lives literally revolve around, was touched for the first time when Parker's solar probe entered the solar corona. After a journey which broke a fair bit of records, it was able to take this image. A coronal streamer with Mercury in the background. After visiting every other major object in the solar system, finally getting to see the view from, in a sense, inside the sun was very exciting. Also, we had the rare opportunity to gather data that will help us better understand solar mechanisms. But of course, you don't always have to get that close. Other observations and models have come a long way, especially here in Boulder. We even recently got the NSO headquarters. And in 2017, we had an opportunity to get a rare look at the sun's corona from our home, Earth. Nick? Sorry, you guys weren't supposed to see that. The Great American Eclipse gave us a stunning view of the corona, a mesmerizingly immersive experience, and historically horrendous traffic. But what a beautiful and surreal experience it was to be part of an entire nation transfixed by an astronomical event. While we're at Earth, I also have to mention an exciting new addition to the CU campus, and I'm not talking about the buff pools, our new SBO telescopes. Although constructed by students, although the 16 and 18-inch will, of course, live in our hearts forever, it's great to have Apollo and Artemis for classes, research, public observing for many years to come. Unfortunately, no one has visited the moon recently, but of course we have still learned a lot about it. From finding an old bit of Earth in a moon rock to learning about hidden ice. And speaking of ice, we have learned so much about our cold, rusty neighbor, from high up in its atmosphere to finally digging into the Martian soil, although we had to lose a friend along the way. Maven has shown us that this atmosphere used to be a lot more like Earth's, but has since been stripped away by the solar wind, disappearing along with ancient surface water. Although water is mostly finished carving out the Martian terrain, we now see evidence that liquid water may still flow in some places. It's clear that this is a very dynamic world, and there's still a lot left to learn about it. There were also many firsts in the realm of interplanetary objects, such as Rosetta, which sent Philae to land on a comet for the first time, or bounce on a comet for the first time, and OSIRIS-REx, which is currently orbiting around this asteroid, Bennu, and will get the first ever asteroid samples. Meanwhile, further out in the solar system, Juno finally reached Jupiter. It showed us a surprisingly strong and uneven magnetic field, dense polar storms, a complex interior, and sent back stunning images. We can now see cloud structure in unprecedented, beautiful detail. And we have our first really good look at the poles. But while Jupiter gained a robot friend, Saturn lost one. Cassini has helped us learn so much about these iconic rings and the moon surrounding him, even sending the Huygens probe to land on the bizarre, enormous moon, Titan. But after 20 years, Cassini made the final fatal plunge into Saturn's atmosphere. Of course, taking data all the way up until its very last transmission. But not all probes crash. Some just keep going and going. Much further out in the solar system, far past all the real planets, New Horizons flew by Pluto and Charon. Although it took a while, it was able to take pictures, send them back to us, and reveal surfaces never before seen, at least by humans. and take lots of data that is still being analyzed today. But of course, it didn't stop there. New Horizons kept going, and after astronomers, including many from here at CU, traveled all over the world to catch a fleeting star shadow, we finally got a look at MU69. And its shape was surprising, which is always an exciting word in science. This ancient object could tell us a lot about the early solar system. We also had the opportunity to welcome an interstellar visitor, Oumuamua, which inspired many headlines and imaginations. But there may be another strange object in our solar system, one that's been here the entire time. So far, we've mainly been focusing on probes, but the discovery of Planet 9 is a testament to the power of theory. And it may be destroyed by theory as well. But you'll have to talk to Professor Madigan about that one. All right, enough about our solar system. Today, we know of 17 exoplanets which orbit in a conservative habitable zone around their star. One of these special worlds was confirmed just a few years ago and happens to be orbiting around the nearest star to our sun. Proxima Centauri b was a phenomenal discovery. Although it looks like this place is very different from Earth, the fact that there's a habitable zone planet around our nearest star says promising things about the number of potential Earth analogs out there. But we have found many other exoplanets, 7 of which are all in the TRAPPIST-1 system. 7 planets. All the planets in our solar system are completely different and unique from each other. Imagine how much we can learn just by looking at what's around this star. TRAPPIST-1 is probably one of the biggest exoplanet discoveries to happen in the past few years. Besides, of course, 40 Eridani, a planet exactly where Vulcan is supposed to be. But all of these are just a handful of the thousands of exoplanets we now know about. Every colored dot that you see represents a star with at least one exoplanet around it. Although its mission recently came to an end, Kepler gave us the first extensive survey of this rather obvious patch of the sky. And now we have TESS, looking all over the sky at nearby stars and gathering lots of light curves. When most of us entered college, 2015, there were around 1,000 confirmed exoplanets. Now, there's over 4,000. We've even been able to image some of these planets, especially ones that are still in formation. ALMA has been really busy the past few years, taken some really phenomenal images, my favorite of which are the protoplanetary disks. When I first learned about system formation, I just assumed there's no way we could ever actually see something like this. But here it is. Thanks to resolving capabilities comparable to being able to see the Statue of Liberty's face from Denver. There's so much out here. At one point, many of us may have laughed at the idea of trying to count all the stars in the sky, or even tried it ourselves and failed miserably. But Gaia is doing just that. This ESA survey has mapped out thousands of solar system objects and over 1 billion stars. A massive stellar census providing us with parallaxes, proper motions, colors, information that has proved invaluable to our field. It's actually looked at so many stars that we can't even show you them all in the theater today. This sphere you see, 1 kiloparsecs, represents the extent of most other large stellar surveys. But Gaia, of course, has been looking much farther than that, throughout the rest of our Milky Way, even looking as far to the large and small Magellanic Clouds, and all the way to Andromeda. A little further out, in the beautiful Virgo cluster, there lives M87. At the center of this enormous elliptical galaxy, and at the base of its relativistic jet, lives an object very popular on the distant planet Earth. I'm sure you all know exactly what this is, but I'm going to talk about it anyways. A black hole. A real, actual picture of a supermassive black hole. The sheer amount of collaboration, ingenuity, and persistence behind this image, along with the fact that it's one of our first glimpses at one of the most mysterious objects in the cosmos, makes this, in my opinion, one of the greatest images humanity has ever taken. And it was just released last month. From more distant galaxies, we have been able to detect something very different: gravity waves. I distinctly remember the day it was announced. I couldn't wait to talk to people about it, but I, along with several of you, actually had a midterm in 1040 that day, which I suppose is important, but what an incredible detection. Over 1 billion years ago, two distant black holes collided. They released an enormous amount of energy and sent out a ripple, a jiggle in the fabric of space-time that made it all the way to Earth and distorted space on the order of 1,000th the diameter of a proton. And LIGO was able to detect that. LIGO has also been able to find several other mergers and even a neutron star collision, the second of which was detected only a few weeks ago. This is changing our understanding of heavy element sources and given us our first visual counterpart to gravitational waves. We now have an entirely new medium to study the universe, one that could lead to exciting discoveries in everything from general relativity to cosmology. We just covered a lot, very fast, and a lot that all happened in the past 4 years. Probably means it's time for another edition of the Cosmic Perspective. I've said the word first a lot of times in this show, which is pretty exciting. Just think, 30 years from now, we might be talking to young students and saying something like, the first clear image of Pluto, or when we found that Proxima planet, yeah, I was an undergrad when that happened. But despite everything we've seen, it doesn't come close to all of the major recent discoveries. Fortunately, there's just way too much to even begin to cover it all. It's also important to remember that astronomy progresses through the work of thousands, most of which never makes headlines. As undergrads, each of us has made progress, whether it's through analyzing data from a planetary probe, helping build a detector, learning how to use Jupyter Notebook, teaching astronomy to kindergarteners, modeling a bizarre magnetic field, or just surviving late nights at SBO. The most common questions I get asked at the planetarium: what's inside a black hole? Does the universe go on forever? Where's the best place to sit? And what's the deal with dark energy? Are mostly questions that no one has the answer to, which is sort of terrifying, but also exciting. So much has happened in the past 4 years on all levels. Who knows what will happen in the next 4? What will we do? What will we discover? It's clear that we are part of an ever and rapidly changing field. Although today we're finished with our degrees, there's still a lot left to learn. Thank you.
Thank you, Claire and Nick. That was wonderful. Claire, I wish we'd recorded that and then we could distribute it to planetarium throughout the world. Great. Next, I'd like to invite to the podium our the recipient of our award for the APS Outstanding Undergraduate, Maya Janez. So Maya, just a few words of introduction. Maya has been a visible and audible fixture of our department ever since she's arrived here. For many of you, Maya's the face of our department. She's worked as the receptionist for our front office and did a wonderful job with that. She's also a fierce and effective advocate for increasing inclusivity in our department, for recruiting and retaining a diverse and wonderful body of undergraduate majors. So we're going to miss her dearly. Maya.
Hi, everyone. Thank you so much for being here today to support our graduates. We worked incredibly hard to make it this far. It is an honor to be speaking to you as the outstanding graduate. I have been lucky enough to be a part of the Astrophysical and Planetary Sciences Department for 5 years. And I've worn a multitude of caps before they would let me wear this one. I've been a learning assistant for the introductory astronomy course, a grader for the department, a research assistant, an undergraduate committee representative, a participant in many of our department outreach activities, and I have been the APS department front desk receptionist for the past 3 years. To describe my time in the department, I would like to give everyone some data. And moving forward, whether we as graduates are researchers, educators, or communicators, data will be involved. So you can't run from it today either. So in 5 years, I've taken 153 credits, 24 major and minor classes. I've welcomed 46 new graduate students and 11 new faculty members. Additionally, throughout all my jobs at CU, I have worked 3,047.5 hours, and I have brewed a total of 10,833 cups of coffee for the department. You're welcome. But our time in this department was not just about data. We have become the scientists and communicators that we strived to be when we arrived at CU. We have struggled, thrived, and persevered through classes, work, research, and life to make it this far, to wear these tassels, and to be commended in this planetarium. I would like to spend some time speaking to my own story of struggling and thriving. I failed Physics 1 the first time. Well, actually, it was the second time. The first time I withdrew. But regardless, that's significant. I failed the first physics class you have to complete to get this major. But presently, I will be attending the University of Southern California in the fall for a PhD program in geological sciences in order to continue my work at NASA's Jet Propulsion Laboratory from the past 2 summers. I am graduating today with honors from the department as the outstanding graduate and with a minor in ecology and evolutionary biology. I have thrived since I failed physics. But just before that semester, I almost dropped out of this major. I had spent the winter break before contemplating whether or not I should take an easier route, whether or not I should change my major. And I would talk to anyone that would listen to me about this. At one point, I was talking to my dad, and I was explaining the situation. And he simply said, "Mija, take the more difficult route, because that's who you are. And that's who we all are as graduates of this department." Having the support of my family and friends, having the guidance of Professor David Brain, and having the amazing research opportunity given to me by Dr. Brian Holler is what I needed to make it through the semester I failed physics. 2 months after I failed physics, I went to my first conference to present my own research as an oral presentation. And a year after I failed physics, I started at NASA for the first time. And now 3 years after failing physics, I'm graduating with honors from this department and going to graduate school in the fall. Not everyone will have this experience. Not everyone will fail a class and be encouraged to stay in this major. And I don't know of anyone else that failed a class and still got research opportunities. But I am the example. I am the reason people deserve a second chance. I had amazing people in my life to push me along the way, to remind me that I deserved that second chance. Thank you so much to Lee for being an amazing partner, and I would have lost my mind long ago without him. Thank you so much to my parents for giving me the opportunity to go to college and for going into as much debt as me to do it. And thank you to Dave, Brian, Morgan Cable, and everyone that gave me a second chance. And that's what I want to share with you. Give people a second chance. You never know someone else's story, and out of failure, success can grow. I'll leave you with one last remark. In the time leading up to World War II, okay, sharp transition, I know. Annie Jump Cannon, an iconic astronomer and my favorite Harvard computer, said, "In these days of great trouble and unrest, It is good to have something outside our own planet, something fine and distant and comforting to troubled minds. Let people look to the stars for comfort. I leave with the same wish. In those times that failure has struck, in those times when sleep is lacking, when the end no longer seems near, and maybe you're wishing you changed your major, look to the stars for comfort. They got you thus far. Thanks.
So Maya's going to be attending the University of Southern California to pursue a PhD degree in geological sciences this coming fall. So congratulations, Maya. Forgot my script. Okay, so next I'd like to welcome to the stage all our scholarship awardees for this year. For the Charles A. Barth Scholarship, Zachariah Milby. For the Cosmic Perspective Scholarship, Caitlin Engelbert. For the Parmenter Scholarship, Aaron Shimoda. For the Sherpin Seal Award, Cooper Wooten. For the Susan Wellesley Scholarship, Claire Lamont, Allison Leffler, Zachariah Milby, Courtney Mushinsky, and Maya Janes. And finally, for the Theodore Snow Scholarship, Carlos Aitan Gary Bicas. So we're going to get our picture taken by Jose, maybe. And then okay, so let's see. Maybe can you do 2 rows? Let's see. Yeah, maybe 2 rows so we can kind of get a clear picture of you.
Is good? Maybe?
Oh, wait. Come on in. Yeah, 1 row. All right, congratulations for our scholarship. Next, I'd like to introduce Professor Seth Hornstein, who is going to announce each student's name and ask them to come to the stage in alphabetical order. I'll hand the students their diplomas, and Jose will take a picture of that, and then the students welcome to make a few brief remarks.
So now the moment we've all been waiting for. I'm pleased to call up the Astrophysical and Planetary Sciences graduating class of 2019. But students, you're not quite done yet. There's one more test. I'd like you to undo all the hard work that Jose has done. I'd like you to line up along the back wall in reverse alphabetical order. While they're doing that, I'll explain why. In 2018, there was a nationally recognized study from the CU Department of Economics that found that students whose names are at the front of the alphabet tend to be recognized more and even go on to more success because of our tendency to alphabetize everything. So today, to even the playing field just a little bit, for those folks who suffer, as they called, alphabetic injustice, we're going to go in reverse order. So students, when your name is called, please come up and receive your diploma from Dr. Halverson. Pause for a moment so Jose can document your accomplishments and all of your family as well. And then you'll have the brief opportunity to say a few words if you wish. Then please go down the opposite side of the stairwell. So without further ado, let's begin. Maya Janes.
swear I'll stop coming up here eventually. But thank you so much to Andy and Byron and my parents for making the trip out here. You guys have no idea how much it means to me. Thank you all.
Kunanon Tongkam.
Thanks, Andrew, for supporting me, and thanks, everyone.
Rachel Sear.
Thanks to my family for coming out here, and this took long enough.
Daniel Schottler.
Thanks to my family, and thank especially to my fiance Jessie for supporting me these last 4 years.
Jonathan Schiller.
I'd just like to thank my family and friends. Without you, I literally wouldn't be here. Thank you.
Adam Owens. Jack O'Hara.
I just want to thank my family and friends for always being there for me and making this all possible. Thank you.
Matthew Murray.
I'd like to thank the faculty for tolerating my buffoonery and for stoking the flames of my curiosity every day.
Zach Milby.
I can think of one hand gesture that will express my gratitude far more than any other, so I'll leave you with this. Thank you.
Cooper Lublin.
I'd like to thank my family and friends for the constant support, and feel better, Mom. Sorry you couldn't make it. Love you.
Matthew Lockridge.
One of the reasons I chose astrophysics is to minimize the chances for public speaking, and here I am, so I'm doing well. But thank you to all of the parents. All of your support, all of your hours, none of these graduates, including myself, could have done it without you guys, so thank you very much.
Robert Lim.
I would just like to thank my parents and grandparents for inspiring me and all the teachers and mentors I had that kept me on the right path. Thank you, guys.
Johnson Lau.
Well, I would like to thank everyone who support me and my family, my both family.
Claire Laman.
This one's for you, Grandpa.
Mendogas Catilius.
I'd like to thank my family and friends and everybody who supported me. Thank you.
Eric Jennings.
Mom and Dad, thanks for believing in me. You're the reason I'm here today.
Tyler Horvath.
Just want to thank my family, Paul, Dave, and Zach, and my best friends, Maya and Carlos. Thank you.
Max Helfer.
In the great words of Stephen Hawking, we are nothing but an advanced species of monkeys that are living on a minor planet around an average star. But what makes us special is the fact that we can understand the universe. So thank you for helping me understand the universe and what makes us special.
Hannah Gretchen Hartung.
I would like to thank Dr. Ellingson and Dr. Schneider and my parents for encouraging wonder when I look up at the sky. Sorry, I'm a second for this sort of thing.
William Hartley.
It's been an incredible journey. Thank you, friends, family, and faculty.
Danielle Hawk.
I'd like to just say thanks to my parents for always supporting and believing in me. Thanks.
Sean Haley.
Just want to say thank you to my friends and family and our awesome professors and my coffee machine, because I wouldn't have made it here without that. And then most importantly, Jack O'Hara, who I wouldn't have chosen this major without.
Carlos Etienne Gary Bicus.
So I would like to thank my friends, the Garis, the Vicases, and my wife, and also Dr. Paul Hain for giving me the greatest job on this planet. Thank you.
Kruti Gunti.
I would like to thank my family and friends and Professor Schneider. Thank you.
Kelly Gadaken.
Mom, Dad, Grammy, all of my brothers, thank you for braving the snow to make it out here and see me finally graduate. And it's been a pleasure grading for you, Dr. Keller. Bye.
Caitlin Engelbert.
Cinderella, I dropped a shoe. All right. Resume, we're good.
I'd just like to take a quick moment to thank my family and friends for always supporting me continuously throughout this journey and always encouraging me to go beyond. I know it's snowing outside right now, but you all are a ray of sunshines in my life, and that's all I need. Thank you.
Vera Demchenko.
As an immigrant and a first-generation college student, these past 4 years have been one of the hardest things in my life. So I'd just like to take a quick moment to thank my mom, my friends, my family, and the wonderful faculty members, and also my incredible Fisk family up there. Thank you for being my rock and support these past 4 years.
Adam Cummings.
I'd like to thank my family for coming out. It's been a crazy, wild 4 years. So, the faculty has made this an invaluable experience, and so have my peers in APS.
Rachel Carollo.
I just want to thank the entire Carollo clan over here, especially my grandmother who flew across the country to see this, and to infinity and beyond.
Alexander Burden.
I'd like to thank my family, friends, and faculty for supporting me through these crazy but very fun 5 years. Thanks.
Elizabeth Bernhardt.
So I can't decide what has been harder in my life, getting an astrophysics degree or being in the Marine Corps, but I know I couldn't have gotten here without my family, my boyfriend, and some of the faculty here, especially Erica. She's making me cry. And Jose, thank you.
Julia Bernard Savary.
I want to thank everyone here at FISC. You guys are amazing. I want to thank my friends and my family. Je vous aime fort.
Zane Barber.
Just want to thank my family and the faculty for an amazing 4 years.
Charles Abad.
I'd just like to thank my brother Jamie, my mom, dad, and grandma for being here, and also Matt for being an amazing friend, study partner, and coworker.
Congratulations to the class of 2019.
Well, this concludes our ceremony. Thank you so much, all of you, for coming. I want to congratulate once again all of our students, and to let you know that we're going to have a group photo in this lovely late spring weather out in front of the planetarium outside. And afterwards, of course, there'll be a reception in the lobby, and please all stay for that. Parents and family and friends, please allow the faculty and graduates to walk out first, and then we can proceed out for the reception. Thank you and congratulations.